So, hello everyone. So, as you know, we are continuing our bridge course. So, the topic for today is periodic table. Where it is. The topic for the day is periodic table. Now what we have to know is, we have to know some things about that. Okay. First of all, we will get a basic definition and basic arrangement of what periodic table is or modern periodic table is. So first of all, we know there are many periodic tables, but what we have to know is modern periodic table. This is the thing, that is the topic for the day. Rest other things are history, and history is not to be discussed too much here. We will discuss it later when we will understand about periodic table in a proper chapter. Here we are going only a brief explanation of that. So modern periodic table was given by Bohr and Moseley. There were two scientists. One's name was Bohr, as you all of you know. Niels Bohr he was, and the other one was Moseley. So two scientists were there, one was Bohr and one was Moseley. So these two have given us the idea of modern periodic table, and the idea of modern periodic table, on what it is based, it is known as the modern periodic law. Modern periodic law. What is this modern periodic law? So modern periodic law is very simple, and what this law tells us, that physical and chemical properties of elements are periodic function of their atomic number. So what do they say is that physical and chemical properties of the elements are periodic function of their atomic number. Those who were before them, they used to say that it is based upon atomic mass, but according to Moseley, it was a new law, and they told us that all the chemical and physical properties are periodic function or repeats itself periodically according to their atomic number and not according to their atomic mass. So what we can say about this, what conclusion we can draw on the basis of this law is, first of all, that modern periodic table, let us write it, modern periodic table in short form, MP. Okay, modern periodic table is arranged according to atomic number. It is arranged according to atomic number. So this is the first thing that is directly told, that can be directly told by the law of Moseley and Bohr. Now, what else we can see is that it is also known as long form of periodic table. Apart from that, this periodic table is formed out of rows and columns. You know, rows are the horizontal things and columns are the vertical things. Okay. So it is formed of rows and columns, okay. And how many rows are there? So here 7 rows are there. And how many columns are there? So 18 columns are there. Okay. These rows are called as periods. These rows are known as periods, and these columns are known as groups. So if somebody asks you how many periods are there in the modern periodic table, So 7 periods are there. Okay. Apart from that, out of these 7 periods, there are vertical groups also, and these are 18 in number. So this is the basic information that I have written or that we have studied till now about the modern periodic table. Okay. Till here, if anybody has any doubt, you can ask. 7 and 18, yeah. So my name is Prashant, those who are asking. Can you be a bit loud? Okay, I will try. Okay, anybody who wants some repetition, please tell me which part is to be repeated. Okay. So conclusion, I am just explaining once again. Modern periodic table is arranged according to atomic number, because Moseley was saying that the physical and chemical properties were based according to were repeated according to atomic number. Apart from that, its other name is long form of periodic table, and it has 7 rows and 18 columns. These 7 rows are known as periods, and these 18 columns are known as groups. That's it. Okay. Now let's move. Let's draw a basic idea of how periodic table looks like. So this is the normal structure of periodic table, where this part is hydrogen and this part is helium. Okay. What we can say is this is the basic idea that you can see. Here only 2 columns. Here it will be 10 columns, and here it will be 6 columns. Apart from that, these are the 7 rows. That is, let us say, okay, this is row number 1 or period number 1, this is period number 2, this is 3, 4, 5, 6, 7. Okay, these kind of periods are there, and if you see in the first area, this is the area number, let us say 1, and let me write it by some other color so that you can understand. And this is area number, let us say 2, and this is area number 3 for now. Okay, and there is one more small area that has to be known, and that is below this, and this will look like this. Here also 2 rows are there and 10 columns will be there. 1, 2, 3, 4, 5, 6, 7, 8, 9, and one more. Okay, this is, you can say, area number 4. This is area number 4. This is the basic structure of periodic table that we have to know. Okay, this kind of structure is the basic structure. Okay, this is the basic idea or basic form of the structure of periodic table. Now let us learn about that, what these things are. Okay, and what these areas represent, what these areas means, what is the specific thing about these areas, what is the specialty of these areas. Okay, let's start by one. First of all, area number 1 is known as S block. Area number 2 is known as D block. Then area number 3 is known as P block, and area number 4 is known as F block. This is the basic structure that you have to know. Okay, so S block, P block, D block and F block. Okay, and now you can very easily think that where they exist, how they are given these names and why they are given these names, that we will get to know. But till here, if you have any kind of doubt, you can ask me. Okay. Okay, let's continue. So, what is this S block? First of all, why this is called S block? Because the elements lying in this block will have their last electron in S orbital. That's why they are known as S block elements. Its example will be sodium. All of you know that sodium has atomic number 11, and what is the electronic configuration for this? 1s2, 2s2, 2p6 and 3s1. That is the part. Okay, apart from that, you can think of lithium, that is also 3, 1s2, 2s1. Similarly, you can think of magnesium, that is atomic number 12, 1s2, 2s2, 2p6, 3s2. I think that's it. Okay, this is how we will get to know, and this is how you will get to know that whether the element belong to S block or not. What are the other characteristics of S block? So in this, what we can tell is very easy, that first of all, it contains two groups that are known as group 1 and group 2. Apart from that, all 7 periods are there. All 7 periods are there, and what will be there is its general configuration is NS1 to 2, where N represents number of period. So in whichever period the element is, it's N and along with S1 or 2. That means that period's S subshell will either have 1 electron or 2 electron. Now you can see sodium, it is a third period element, so its 3s is having 1 electron. Similarly, lithium is a second period element, so its 2s is having 1 electron. Similarly, magnesium, which is again a third period element, so its 3s is having 2 electrons. These kind of things are there. Okay, this proves us about the S block, that what is S block. Okay, so till here I don't think so there is some kind of doubt. Now, let us move to the new block, next block, that is D block. D block it is, okay. So, what we can say is now D block. So, in these last electron will enter in d orbitals. Okay, the last subshell will be d subshell, or we can say last filled subshell will be d subshell, and the last orbital in which electron is filled will be a d orbital definitely. Okay, these are the d block elements. What we can else say about this is that their last electron is filled in penultimate shell. Penultimate shell. Now what is this penultimate shell? So penultimate shell is one after the outermost. One after the outermost is known as penultimate shell. Like if you think of some d block element, let us say scandium, that is having atomic number 21, okay, and what will be its electronic configuration? So it will be 1s2, 2s2, I am writing for the sake complete, okay, 2p6, 3s2, 3p6, 4s2, 3d1. Now you know that outermost shell will be 4s because it is having highest n value. Whatever is having highest n value is considered as the outermost shell. So this is known as ultimate shell, and whatever is inside, that means third shell, it will be considered as penultimate. So fourth will be considered as ultimate, fourth one will be considered as ultimate, and third one is considered as penultimate. So we have to say always that electron will go into penultimate shell. Apart from that, think about one more thing, that what will be its general configuration. So general configuration will be ns122 and n-1 d 1 to 10. That kind of configuration will be there. ns122 and n-1 d 1 to 10. Okay. So n represents the ultimate shell, that is the outermost shell, and n-1 represents the penultimate shell. Apart from that, n can be equal to 4, but n cannot be less than 4. Not possible. For example, in third period there is no d block element possible. At least fourth period it is there. The first d block element will be there in the fourth period. Is it okay? Before fourth period there should be no d block elements. This is the things about d block elements. So till here, if anybody has to ask something, you can ask. Those who are asking Telugu cheppandi, I should say Telugu radu. Okay, let's move to the next. So the next one that we have to know is P block, and that is very, very important. One more thing that we have to know is, it contains 4th, 5th, 6th, 7th, 4 periods, and apart from that it contains 10 groups, that is group number 3 to group number 3 to 12. Okay, 3 to 12, 10 groups are there, and apart from that 4 periods, 4, 5, 6 and 7, 4 periods are there. These are involved in D block. Now let us move and let us discuss about P block. So what we can say about P block is, so first of all, their last electron will enter into P orbital. That means its last filled subshell will be a P subshell, and the last filled orbital will be a P orbital. Okay, so last electron will be filled into P orbital. Apart from that, again it will contain 6 groups and 1 to 7 all periods. All periods will be there and 6 groups will be there. Is it okay? Which 6 groups will be there? So it will be group 13, 14, 15, 16, 17 and 18. Okay, and some of them also have some names. Okay, like 17 group is known as halogen group. Similar to that, 18 group elements are known as noble gases. Okay, so halogens, noble gases, these kind of names are there for some of their specific groups. Okay, apart from that, their general configuration, is what? So it is NS2 NP 1 to 6. So these kind of things will be there. NS2 NP 1 to 6, where N is the number of period. For example, you can think of sulfur, that is atomic number 16. So what will be the configuration? 1s2, 2s2, 2p6, 3s2, 3p4. Now see, third period element, so 3s2, that is ns2, and np4, that lies between 1 to 6. So these are the things that you have to know. You can think of something other also, let us think about aluminum, that is 13, that is 1s2, 2s2, 2p6 and 3s2, 3p1. See again, 3s2, 3p1, third period. You can think of, let us think about some fourth period element also, and it will be, let us think, gallium, or instead of gallium, and germanium. Okay, so germanium is what? So it is nothing, 32. Okay, gallium is 31 also, you can write by your own, no problem is there. So it will be 1s2, 2s2, 2p6. Okay, apart from that 3s2, 3p6, 4s2, 3d10 and 4p2. This kind of thing is there. You can see here 4s and 4p, that is ns and np are there. Okay, so by this you can conclude the same thing, that ns and np, so that is also satisfying the general configuration. So this is for germanium. For gallium 31 you have to write by your own. Okay, you can write by your own very easily. Now this is about p block. Let us think about the next block, that is known as f block. These f block are also known as inner transition metals or inner transition elements, to be more precise. Inner transition elements they are. Okay, so what we know about them is, first of all of them lies in group 3. All of them lies in group 3. Apart from that, in them, how many? Same. So, and in case of periods, they lie in 6th and 7th period only. There are only 2 periods, 6th and 7th. Okay, so in group they are all lying in group 3, and in terms of periods they are 6th and 7th. So one more thing, in them last electron enters into f orbital. Okay, last electron enters into f orbital. Apart from that, this f orbital is known as anti-penultimate. Anti-penultimate. As I told you that we can say that last electron enters into anti-penultimate shell. As I told you that ultimate means outermost, then one inside it is known as penultimate. After that, the one inside the inside one, that means second from outside, that is known as anti-penultimate. So f orbitals are always anti-penultimate. So what we can write about this is ns2 n-1 d 0 to 1 and n-2 f 1 to 14. This is the general configuration for any of the f block elements. Okay, this is all about f block. Now let us think about s block. Okay, general configuration we have got, how many periods, how many groups. Same for d block, how many groups, how many periods. Similar for p block, how many groups, how many periods are there, and similar to that f block is there. Okay, one more thing is there, d block elements are also known as transition metals or transition elements. Most of them are metals, transition elements. Okay, let me tell you why they are known as transition elements. See, this is known as s block, this is d block, this is p block. So s and p combinedly are known as main groups. Okay, s and p combinedly are known as main groups. So when you are transiting from s to p, that is moving from s to p, you have to move through d. Like d will come into transition, that is inside the way. That's why it is known as transition. And these all f block, all f block elements, these start from here. Their first period and second. So from here and here they start. So this and this, like this element is lanthanum and this is actinium. Okay, and it can be written here also, lanthanum and actinium. These two elements are which are part of this d block and f block. Now they lies after lanthanum, so they have to be lied inside this d block or inside these transition elements. That's why they are known as inner transition elements. So this is about the elements which are there, or this is about the blocks of periodic table. Till here, if anybody has to ask something. Okay, now we can move. Let us move to two more things. The thing is, one thing is hydrogen. Now, there are two groups in this periodic table, that is group 1 and group 17. So, what is the group 17 kind of thing is, and group 1 kind of thing is? Group 1 is always NS1 to 2. Similarly, group 17 is what? NS2 NP5. If you think about both of them, their valency, its valency is 1, means not 1 to 2 actually, it is S block complete. Now, so group 1 configuration is NS1 and valency is 1. Similarly, group 17 is NS2 NP5 and its valency is also 1. The difference is this lose one electron to form a cation. Similarly, this gain one electron to form a anion. So these are the two things, cation possibility and anion possibility. Now hydrogen, as we know, it has 1s1 configuration. So it can lose one electron and form 1s0, that is known as H plus, also known as proton, H plus kind of ion, or it can also gain one electron and form 1s2, that is known as H minus, that is called hydride ion. So it can behave some things like group 1 and some things like group 17 if you see. Like group 1, in terms of group 1 it is losing an electron, whereas in terms of group 17 it is gaining an electron. Both things it can do. That's why if you see in any kind of periodic table, hydrogen is placed here. This is the separate place for hydrogen. We can sometime call it in group 1, but we do not exactly involve it as a group 1 element. The group 1 elements, other group 1 elements are known as alkali metals. But hydrogen is not considered as alkali metal. First of all, the basic thing that you know about hydrogen is it is a gas. It is a non-metal. It behaves, this kind of features are separated or different from alkali metals. So even if it is lying before group 1, it is not considered properly a part of group 1. Instead, it is considered as a separate thing. Is it okay? When alkali metals will be discussed or group 1 will be discussed, never consider hydrogen. Hydrogen is not considered as a group 1 element. Okay, that's it. Now, till here, if somebody has to ask something, you can ask. Okay, till here no doubts are there. So what we have read till now, let's revise a little bit. Okay, so we have learned about periodic table, that what is periodic table. So what we get to know about this is that there is a modern form of periodic table, that is a new periodic table that we have to know. History we are not involving for now, history we will study in later parts. Okay, what we get to know that this modern periodic table was developed by Bohr and Moseley. Okay, and Bohr and Moseley were the two scientists that have given a modern periodic law on which this table was formed. Okay, what was this law saying? That physical and chemical properties of the elements are periodic function of their atomic number. That means the physical and chemical properties repeat itself according to atomic number, means they will repeat after a set of or after a number of atomic numbers. Okay, after a fixed interval they will repeat itself. These kind of things are there. Apart from that, modern periodic table is arranged according to atomic number, as the law say. Apart from that, it is called as long form of periodic table because it is very long. Apart from that, it has 7 rows and 18 columns. These 7 rows are known as periods and these 18 columns are known as groups. So 7 periods and 8 groups are there in the periodic table. Then after this, we have seen the basic structure of periodic table, in which we have got that what is this S block, what is this D block, what is this P block, what is this F block. Now after this, what we have to do is we have to read S block, P block, D block and F block one by one. So in this S block, we have learned about who are the elements which are lying in the S block. So those whose last electron enter into S block, what it considers, what it contains 2 groups and 7 periods that we have told, and the general configuration is NS122. Then after that came D block. D block is also known as transition elements in which last electron will enter into D orbital. Apart from that, this last electron is filled into penultimate shell. Penultimate means one after the outermost. So there is an example, scandium, in which outermost the last electron is filled in 3D subshell, whereas the outermost shell is 4th one. So it is penultimate shell. Apart from that, we got to know the general configuration, that is NS122 and N-1D1 to 10. N-1 means outermost minus 1, that is the penultimate. Okay, and N is the outermost period, or N represents the number of period directly. So how many periods? 4, 5, 6, 7, 4 periods are there. Apart from that, 10 groups, that is group 3 to group 12 are there lying in the D block. After that exists P block, in which there are the last electron of this block will enter into P orbitals. Apart from that, it contains 6 groups and 7 periods. Okay, 6 groups and 7 periods. One more thing, let me tell you. There is only one group in that noble gases that contains elements in all 7 periods. Elements in all 7 periods. All other groups start from period number 2. Okay, all other groups, that is group 13, 14, 15, 16 and 17, they all start from 2nd period. That's it. Okay, and group 18 start from 1st period. Apart from that, this is their general configuration, NS2, NP126. Okay, apart from that, this N tells us about the number of period as usual, and then there are some examples. Let us move. Then F block, those are known as inner transition elements because they lies inside the transition elements that we have already discussed. Apart from that, all of them lies in group 3. They are the part of group 3 only, as I have told you, like here only. This is group 3. Okay, this is group 3, this is group 1, this is group 2, this is group 3. So all of them are, that's why all of them are written here. They are part of group 3 only. So apart from that, there are 2 periods only, 6th and 7th, and last electron enters into F orbital, and F orbital is of anti-penultimate shell. Anti-penultimate means last is ultimate, then one after last is called penultimate, and then third one, or from last third one is known as anti-penultimate. So these kind of things are there. This is their general configuration: ns2 n-1d 0 to 1 and n-2f 1 to 14, where n represents the number of period as usual. Apart from that, later we get to know that hydrogen have some properties similar to group 1 and some properties similar to group 17, but we did not consider it as a part of either group 1 or either group 17. We just keep it above group 1 and we consider it as a separate element. We study its properties as a separate element. As you know, group 1 is known as alkali metals, and I told you that hydrogen is not a part of group 1. So I think that's enough for today. We will stop at here only. Okay, that's it for today. If anybody has still any kind of doubt, you can ask, or after 2 minutes I will end the session. General configuration and electronic configuration. Let me tell you, general configuration is the configuration for a complete group, complete block, okay, and electronic configuration is separate for each element, okay. General means for generally complete block. We are talking about a complete block or a bunch of elements we are talking about. Then we write general configuration. Electronic configuration is for every element. For every element of that block or that bunch, we can write a separate electronic configuration. That's it. Why change the periodic table? Because earlier periodic tables were not explaining correctly all the properties. Like Mendeleev's periodic table, that was not enough to explain all the properties. It was not explaining about what are isotopes and how to place isotopes. These kind of things are there. Okay, I think that's enough for today. Okay, that's it. We'll meet in the next class.